Welcome back to the second part of this lesson for section 4.1. This is where we left off. So our notation for antiderivatives, we said, hey, remember what it looks like when we're finding a derivative. And I'm going to just say that that derivative equals some kind of function. And then I'm going to rearrange it like this in this next line. Again, I'm allowed to do that. I'm allowed to break up that dy dx. On the next slide, we're going to see why we broke that up. And then we said, okay, this process of finding the solution is called antidifferentiation, which took me about a year to actually spell. And then it's also called integration, okay? And then we have this symbol down here, our integration symbol, okay? So why did I rewrite that thing? Well, here is why. If I say that I have dy equals f of x dx, then I can do this integration process, which is basically going to kind of undo some things, okay? I could say I'm going to find the antiderivative of both of these sides. This is going to become just y equals the integral of, or the antiderivative of f of x with respect to x. And that's going to just equal your antiderivative, which again is some function, but I'm using an uppercase f to represent that it is an antiderivative, and then plus my constant over here, okay? So this function, we have a fancy name for it. It is called an integrand, the thing that you are integrating. Whatever you see over here, dx, d theta, dz, whatever it is, that is going to be your variable of integration. It's going to tell you what you are integrating with respect to. Over here, this would be an antiderivative of f of x. And then again, it's just an antiderivative because, I don't know, there could be some kind of constant. So this over here would just be our constant of integration. Okay, so you will be dealing with a lot of problems that look very similar to this. And we're going to walk through exactly this process. How do I get from this stage to this stage? It's finding a derivative, but in reverse. So let's look at some of your basic integration rules over here. This one is saying, for differentiation, if I say find the derivative of a constant, well, that derivative is going to be 0. So when you're integrating, if it says find the integral, the antiderivative of 0, well, it's just going to be a constant, c. And I don't know what that constant exactly is going to be. Over here, if I said find the derivative of k, k also just represents a constant, times x, well, then you're just going to say k, right? So if I ask you what is the derivative of 4x, you would just say 4. Over here, if they're saying, hey, would you please integrate k with respect to x? Well, then it's just going to be whatever that number is, kx plus c, right? I need to make sure that I'm adding in that c. There could be some kind of constant. So, for example, this would be like, hey, find the integral of 2 dx. Well, that would be 2x plus c. All right. Again, if you need to check yourself, do this process in reverse. What is the derivative of this side? Well, just 2. And that's exactly what we see as our integrand over there. Okay. Over here, if you have some kind of number like k, again, that's a constant, times a function, you can always pull that k kind of out in front, and then you're just taking the derivative, right? We can do the same thing on the integration side. If you see k f of x as your integrand, you can feel free to pull that k outside of your integral symbol and then just take the integral or find the antiderivative for whatever's left for that function. These two rules over here are just saying, if you're adding or subtracting functions, then you would find their derivatives and add or subtract them, or you would find their integrals and add or subtract them. And then this is where it gets exciting down here. Power rule. This is what you've been doing for a month and a half, weeks, a long time. If you have something like x to the third, your power rule would say, okay, well, dx of x to the third, I'm going to pull that 3 out in front. I'm going to leave my base, and I'm going to subtract 3 minus 1, gets me 2. That is your power rule. You've been doing that in your sleep. This over here is your power rule for integration. If you see x to the end, we're going to do it in reverse. Instead of subtracting 1, I'm going to add 1, and then I'm dividing this entire thing by n plus 1, okay? Because you are dividing by n plus 1, you can't have n equal to negative 1. That's their little caveat over here. All right, this is a big one. Pause this video, write this down. Make sure you have this one somewhere. You're going to be using this a ton. On the next slide, Again, pause this wherever, like, do what you got to do. I want to make sure that we're going to get comfy with this stuff. You will have access to all of these integration rules. Like, I'm going to post just these slides as well as this video. If you are someone that does well learning by writing things down, then write all these down, okay? Maybe for something like a quiz, I would give you some of these, but by the time we get to the test, you will have these locked in, okay? Again, on this side, these are all of your differentiation ones. On this side, all of your integration ones, it's just in reverse, right? So if I know that the derivative of sine is cosine, well, then if I see cosine as my integrand, then my integral is just going to be sine, right? It's just flip-flopped. If you see secant squared as your integrand, well, then I know that secant squared is the derivative of tan, so that means my antiderivative is tan, all right? So see how it's just kind of flip-flopped? So if you want to, take a second, pause this, jot these down. Be careful with the negative ones, right? So I know that my derivative of cotangent is negative cosecant squared. If you just see cosecant squared as your integrand, make sure that it's negative cotangent, all right? They just kind of are moving around that negative a little bit. So write down whatever you want to write down. Otherwise, just have these up while you're doing your homework later. They eventually will just get lodged into your head. Okay, example 2. Describe the antiderivatives of 3x. So our problems from here on out are going to look like this. That's my integral symbol, 3x with respect to x. I'm allowed to pull that 3 out in front. So then I need to figure out, okay, what is the integral of just x? Well, I know that it's just going to be 3. And then using my power rule, I'm going to have x. That's kind of a little sneaky little 1, power of 1, right? So x to the 1 plus 1 would be x squared. And then I'm going to divide that whole thing by 2, okay? And then I need to make sure that I'm still adding my constant, all right? So what we did here, we rewrote it. I used the power rule, and I made sure to add in my constant of integration. So your final answer here, then, if I'm trying to, find my antiderivative, I could say like capital F of x. They didn't really give us that info. You'd say y, whatever, equals 3 over 2 x squared plus c. And if you're ever not totally sure about your answer, then just do this problem in reverse. So to check it, what is the derivative of this whole thing? 3 over 2 x squared plus c. C is just any random constant. That would get you right back to where we were, 3x. Okay, you do not have to do this part. It can just be a helpful tool, okay? But for this one, this right here would be your final answer. We have a few more problems. Let's do them. Okay, I have to give you this problem. Describe the antiderivatives of, okay, here's this whole thing. 3x to the 4th minus 5x squared plus x. So what would those antiderivatives of that whole polynomial be? I want to take the integral of this whole entire thing with respect to x. What we can do is we can apply our sum difference rule, and I am totally free to split these all up into separate pieces. So what is just the integral of 3x to the 4th with respect to x? Minus what is the integral of 5x squared with respect to x? Plus what is the integral of x with respect to x? And notice, yes, I did write dx for each one of those pieces. Again, that's just telling you right now, okay, it's kind of like, yeah, all right, everything is with x. We're just going to use x. But that is just telling you that is what you are integrating with respect to. Okay, that's the variable you're focusing on. Okay, I am totally welcome to pull that 3 out in front. Then using the power rule, I would say, okay, x, 4 plus 1 is 5, divided by that 5. Okay. Minus, I am allowed to pull that 5 out in front, then I'm left with an x squared. So power rule would be x, 2 plus 1 is 3, and then you're dividing by that 3. Plus, over here it's just x, so that's like x to a sneaky 1. X, 1 plus 2 is 2, and then you're dividing by that same number over there, okay? And then we cannot forget that constant plus c, all right? If you want to simplify this a little bit, like I think that kind of looks a little janky, so I would rewrite this as 3/5 x to the 5th minus 5/3 x to the 3rd plus 1 over 2 x squared plus c, and that would be our final answer for this problem. If you need to check it, take that antiderivative and find the derivative of it and see if it matches with our starting function, okay? You have some Delta Math problems that will be very similar to this. Again, I'm trying to set you up well by giving you a bunch of resources. Hit this topic hard so that by the time we get to the more complicated problems, you're feeling comfy with this, okay? If you needed a clean break in calc, then treat this as your clean break. This is your fresh start. Just go full speed ahead from this point on. All right, let's get into some trig. I'm trying to find the integral of sine x over cosine squared x, all with respect to x. Use those integration rules. So that's the first thing I'm going to say. Use the basic integration rules that I gave you. They're going to help us out a ton. When we are dealing with trig problems, sometimes it's helpful to rewrite them first. So I know we're kind of used to taking something and rewriting in terms of sine and cosine, but when I look at this, like I have not taught you how to deal with a fraction that looks like this yet. You only really have access to those basic trig rules. So what I want to do is I want to somehow rewrite this to make it look like one of those integration rules, okay? It's okay if I'm walking through this problem and you're thinking, I wouldn't have thought of it. That's fine. That's why I'm teaching you this, right? That's why we're going over this. But then once you start tackling trig problems, I want you to be a little creative with it. Think, how could I rearrange this? How could I rewrite this? How could I replace this with another trig function, equivalent trig function, not just any, to get it to look like one of those rules? So here's how I would tackle this one. I would split this fraction up into 1 over cosine x times sine x over cosine x, okay? If you don't believe me, multiply these back together and see that we're still just sine x over cosine squared x, okay? All I did was I just split up this fraction. Everything is still multiplied. It's completely legal. We're good to go. What is 1 over cosine x? Like, that's another trig function. 1 over cosine x I could replace with what? Cool, secant x. And then sine x over cosine x, what could I replace that with? Hopefully you all said out loud together in the classroom with a sub, tan x. Okay, look back at your integration rules. If you need to literally scroll the video back, or if you wrote them down, check your list. What's our answer? Another way to think about it is, what trig function has the derivative secant x tangent x? Going back to those rules, my antiderivative here is going to be secant x, and then it can never forget that c. You always have to have that c, right? I could have secant x plus 2, and I would still end up getting that secant x tangent x as my derivative. Alrighty, folks, that is your last problem. If you need to, go back to parts of this video, review some of it as you're working through the homework. I do really want you, like, please, at least skim section 4.1 in your textbook. It gives you a couple of different examples that could be really helpful. Otherwise, be working on your homework and be working on Delta Math. Good luck.